All right, so we finished 8.2, and 8.3 talks about what we call dot products and vector projections, okay? The mathematics of it is actually like rather straightforward, but conceptually, let's talk about what it means. So suppose you have two vectors like this, the blue and the green, right? And now suppose you were to shine a flashlight here, like this, right? And you hold the flashlight so that it's perpendicular to the green vector, right? That's like 90 degrees with the green vector. There is going to be a shadow of this blue vector on the green, right? Right, like if you hold a light on it, the blue vector is going to cast a shadow onto the green. That shadow, in math, we don't call it a shadow, we call it a projection. But basically, the projection is the shadow that A will cast on B, okay? And the length of the shadow will be that, that much, and that's what the projection is. Now, if I were to take that projection, that length of the shadow, and I multiply it with how long the green vector is, I get the dot product, okay? So dot product is the length of the shadow times the length of B. All right? So that's what a dot product is. All right, how do we find a dot product? Well, if you have A and B, then the dot product is this. All right? Now, the way we write dot product is we say A dot B. Okay? And the way you do it is A1, B1, A2, B2, just like that says over there. All right? So you multiply the first numbers with each other, the second numbers with each other, and then you add them to each other. Okay? All right. So let's draw these two vectors here and find their dot products. All right? So let's draw vector U. I'll draw it in the blue here. Vector U is -3, 4. So I go -3 and 4. That's what vector U looks like. Okay?
If you don't put the dot, why does it?
I'm just drawing vector U.
Why does it come from 0, 0?
Well, everything starts at 0, 0. And then vector V is 3, 6. Okay? All right. So that's vector V. All right. If I want the dot product, all right, that will be, that'll be the shadow that U casts on V times the length of V. And the way I do it, U dot V, okay, I take the first ones, -3 times 3, plus the second ones, 4 times 6. Okay? So that's -9 plus 24, 15. Right, so you're just going to get a number. Okay? All right, so let's do, yeah, that's very straightforward. So let's do this other one. U is 2, 4. Okay? And then V is -6, 3. And that's going to be 2 times negative 6, always plus, okay? 4 times 3. 4 times 3. So that's negative 12, positive 12. That's 0. Okay, so what happened there? When you look at u and v, right? The way u and v are situated, the angle between them is 90 degrees. Okay? The angle between them is 90 degrees. So, if the angle between two things is 90 degrees, like this one, okay, like u and v, and if I cast a shadow that's perpendicular to v like this, right? How much, so like if this is my shadow, like if this is the light, right, that's going down like this, how much shadow is u going to cast on v? How much shadow is that going to have? If you have a light directly on top of you, do you cast a shadow on the ground? None. So there's not going to be any shadow, right? So if the light is coming this way and it's perpendicular, because it's perpendicular, there's not going to be a shadow. If there's no shadow, then there's no dot product, because the dot product is the shadow times the length. Okay? So if they're perpendicular, there is no dot product. Also, if the dot product is 0, it means that they're perpendicular. Okay? With vectors, we don't call them perpendicular, we call them orthogonal. Right? So let's think about what that word means, like orthogonal. What's an orthodontist? What does he do? What does the orthodontist do to your teeth? He makes them straight, right? And what does an orthopedist do to your bones or to your like spine? Make sure it's straight, like make sure it's what it's supposed to be. So ortho means straight, right? So orthogonal vectors have like a, you know, it's straight, it's perpendicular. So if the angle between two vectors is 90, then the dot product will be 0. Okay, and we say they're orthogonal. All right. Let's do some more vector stuff here, more dot products. All right. All right, so here we have u, v, and w. We're going to do u dot v. So that's u dot v. Okay. So just like before, go ahead and do u dot v here. I'll give you like a minute. Just do u dot v and stop. Right? So you have 2 times 5, and then plus negative 1 times 4, so it's 6. Right? Okay. Here, the next one is w dot v plus u. Okay, so you could either do w dot v and then w dot u and add them. It's easier to do the parentheses first and then add the rest, right? So, how much is v dot u? So w is 7, negative 2. Okay, dot. How much is v plus u? Right, we're just going to add those, remember? So it'll be 5 plus 2, comma, 4 minus 1. 7 and 3. Okay? And now, the dot product here, it's going to be 7 times 7 plus negative 2 times 3. So 49 minus 6, 43. Okay. All right, let's do v dot v. Same vector with like the dot product of v by itself. I'll give you like 30 seconds to do that one, v dot v. So we get 41 for this one, and then we're going to do 3 times, we do v dot w first. V dot w, 5 times 4 plus 4 times negative 2. Let me write it this way. Huh? Oh yeah, 5 times 7. Okay? So this is 3 times 35 minus 8. How much is that? Right. Okay? All right, so we know about dot products now. It's pretty straightforward, right? Okay. So let's talk about how do you find the angle between the two vectors, okay? The angle between two vectors, right, is that's pretty much what it looks like. You have vector A, vector B, and this is the angle in the middle. We have a formula that gives us the cosine, and then we have to do inverse to find the actual value. And this is our handy dandy formula. All right. So on top, that's a dot product here. Right. And then what did those absolute value bars mean? Remember? Those are the magnitudes of A and B. Okay. So here I have one vector and another vector. I need to find the angle in between them. Okay. So I go in shifts here. So first, let's find dot product. All right. Eventually, my formula is going to be this. Cosine of theta is, all right, the formula is A dot B, but I'm given U dot V, U and V. It's fine. We do U dot V over magnitude of U, magnitude of V. Okay, so first we do dot product, U dot V. That's going to be 1 times 2 plus negative 4 times 6. So 2 minus 24, negative 22. Right? And then I'm going to do the magnitudes. Do you remember how we did magnitude? So first let's do magnitude of U. The square root, exactly. 1 squared plus 4 squared. That's equal to root 17. And leave it like that. Okay? And then for V, the square root of 2 squared plus 6 squared, so root 40. Okay? All right, so here's what we're going to do. Let's plug it all in. So cosine of theta is equal to U dot V, I said, was negative 22. And then root 17, root 40. Okay. Let's go on our calculators. All right, so let me clear all that junk. Okay. So I have negative 22 divided by, in parentheses, divided by, in parentheses, the square root of, okay, so here's how you could do it. You could either do it like this, the square root of 17 times the square root of 40, and then close the parentheses. Geez, why is it double? Right? And that'll give you that. Geez, okay. Or you could do this. Negative 22 over the square root of 17 times 40. Same exact thing. You see that? All right, so cosine of theta is negative 0.8437, but then theta is inverse cosine of all that. So I do inverse cosine of the answer, and it's 147.5 degrees. right? So to get the same answer, or to get the most accurate answer, always do like second answers so that you're not rounding, okay? All right, so let's just think about that for a minute, okay? Let me graph those two here. What were those vectors? U and V, right? So U is 1 and -4. 1, 2, 3, 4. So it goes like that. And then what's V? 2 and 6. 1, 2, 3, 4, 5, 6. Right there. Okay, and that's V. Does it make sense that this angle is 147.5 degrees? It does, right? So always have that in the back of your mind. So, you know, just visualize, okay, 1 and 4 goes that way, da-da-da goes that way, and that. Okay? All right, so that's how to find the angle. Now, how do you find the projection? Remember how I said the projection was if you cast the shadow, like if you hold the light, it's the shadow. Okay, now how do you find like the actual shadow as a vector? All right. So to find the projection, there are two pieces. The magnitude is this formula here. Okay. And then the actual vector form. So this top one just gives you a number, okay? How long the shadow is. Okay? This gives you the vector form. All right, so we're going to find the projection of A onto B. Let's just draw that first and see what it looks like. Okay, so what do we have here? We have -1 and 5. I'm going to try to do it on here. -1 and 5. That's A, right? And then B is 4, 6. Okay, so if I go perpendicular to this, like this, okay, do you see how like A can be mapped onto B like this, right? So if you go perpendicular, this is how much A will have a shadow on B. So this will be the shadow, A's shadow on B. Because it's got to be perpendicular to B. It's got to be 90 degrees to B. That's how that's the thing. Okay? So that'll be A's shadow. So the first part, right? The projection, first we have to find the magnitude of that and then give it a vector, all right? So let's find the projection. All right. I'm going to use that second formula. Here, I'll write it here. So projection of A onto B, it's going to be that second formula. That's A dot B over B squared times vector B. Okay? All right, so let's do it in shifts again. So first A dot B. What is that going to be? $26. Okay? And then I need magnitude of B. Well, that's going to be the square root of 24 plus 16 plus 36. So 52. Okay. But what I need is not magnitude of b, but magnitude of b squared. So if I were to square that root 52, what would it be? Just 52. So now we put all that in there. So it's going to be 26 over 52 okay, times vector b. Where is vector b? That's this one, 4 comma 6. Okay, so what's 26 over 52? One half times 4 and 6. And do you remember how we did this? You just distribute. So finally, my projection is 2 comma 3. Okay? All right, so what does that look like? Here, if I go 2, so I got the projection to be 2 comma 3, right? So if I go 2 comma 3, look at where, okay? So that's the projection, right? So I miscalculated my angle a little bit, right? So it's got to look like that. Okay? So that's the projection of A onto B. All right, so next one is your turn. Find the projection of U onto V here. All right, I'll give you like 2-3 minutes to do that. This is what we got for the projection of U onto V, right? Okay, so now, why do we care? Why do we do this? Well, the most obvious, there are lots and lots of applications, but the most obvious is when we talk about how much work is being done, right? So in physics, the concept of work, okay? Work happens when you apply force onto something and that something moves, right? So you could be pushing against this wall with all your might for like 10 hours straight until you're like sweaty and blue and whatever. If that wall doesn't move, yes, you've applied a lot of force, but you've done zero work, all right? So in order for work to be done is force must be applied and something has to move. And when that motion happens, right, the force that was applied in the direction of the motion is what makes work happen, is the part of the force that figures into our formula, okay? So the most official definition for work is actually F dot D, okay? So the definition for work is F dot D. It's the dot product, which means it's FD cosine theta, okay? So if you apply, like if I were to like push this table, I don't get down and like, you know, push it horizontally like this. I just apply a diagonal force. That force, remember, has a vertical and a horizontal part. The horizontal part of the force is what's responsible for moving that table. The vertical portion of my force pretty much is wasted when it comes to work, okay? So you have somebody pushing a box with a constant force of 40 newtons at a constant angle of 45 degrees, right? And, oops, this should say find the work done in joules to move the box 12 meters, all right? So what do we have here? We have a force of 40 newtons. We have an angle of 45 degrees. And then we have a distance of 12 meters. Okay? So work, we just said, was FD cosine theta. So this is 40 newtons times 12 meters times cosine of 45. So pretty much that's 40 times 12, and cosine of 45, we know that's root 2 over 2, right? I mean, we're going to put it in the calculator anyway. Okay? that will be 40 times 12 times root 2 over 2. Of course, you could have simplified some things and have done 40 times 6 times root 2, but let's just do it that way. We're going to get 339. Okay, what were the units? I had a Newton and a meter, which that's a joule. It combines to a joule. And all the energy and all the work is measured in joules. Okay?